Hi everyone. In this video we are going to discuss about nuclear chemistry. So what is nuclear chemistry? Everybody know nuclear chemistry is a branch of chemistry which deals with the properties of nuclei and the changes happening inside the nuclei. So first we'll see about more fundamental details about the nucleus. Every atom is having a tiny central core portion. So imagine this is an atom. So this tiny center core portion is known as nucleus, and the radius of the nucleus is of the order of femtometer, and 1 femtometer is equal to almost 10 to the power minus 15 meter. This is the relation of a femtometer with meter. Then so we can say that an atom is almost 10,000 times larger than the nucleus. So that means our nucleus is an incredibly small thing, but it is having the whole positive charge of an atom. So this is the most dense substance, or it is having a very high density, as the most mass of an atom is concentrated inside the nucleus. So a nucleus contains positively charged protons as well as an electrically neutral neutrons. So this protons and neutrons inside is collectively known as nucleons. This is known as nucleons. So the number of protons present in an atom, it is called atomic number Z, which is known as the number of proton number. Then the sum of protons and neutrons inside the nucleus is known as mass number. This is the A, which is represented by A, that is the mass number. So then we can say a species of atom characterized by the constituents of its nucleus, that is the number of neutrons and protons it contains, that is known as a nucleoid. So we can the general representation of a nucleoid can be represented by X. X means like hydrogen, helium, lithium. It can vary, and its proton number we have to write in the down portion and mass number we have to write in this portion. So this is the general representation of a nucleoid. So here you will be writing the mass number on the top and the proton number at the bottom portion, and whereas the X is a chemical symbol of what is the element. So A, which we are writing as superscript on the same side of Z itself, which represents the mass number. So mass number means what? Mass number means number of protons plus number of neutrons. This means protons, number of protons plus number of neutron. So as an example, I can say we can write carbon as 12 and 6. This is the general representation of a carbon, and which is carbon which is having mass number of 12, and it's an isotope of carbon which is having mass number of 14. So these are two different nucleides of carbon, and here this one is having 6 proton and 6 neutron, whereas this one, the second one of carbon 14, it have 6 proton plus 8 neutron. So we can say basically isotope will be having more number of neutrons inside that. Then so now the term what we have to discuss further is depending upon these changes, depending upon the changes in neutron number and proton number, etc. So there comes the three terms which we have to discuss. So this is the basic portion of a nucleus or how its representation and all. So now we are moving into another section, that is the three terms which we have to discuss is isotopes, isobars and isotones. Isotopes. So what is an isotope? Isotopes are nucleides that have the same atomic number but different mass number. So isotope means they have same atomic number, different mass number. So since isotopes are having same atomic number, we have discussed it previously, that means they have same number of protons in them. Atomic number means that they'll be having same, suppose if two substances are isotope, means they'll be having same number of protons. They are thus the atoms of same element itself, but it will be having it will be having almost identical chemical properties as well. Since they have difference in their mass number, so there will be different physical properties and rate of reaction, because mass number is basic, that is depending upon the number of neutrons. So as a result, the isotopes are substances which have same chemical properties but different physical properties. So suppose if two elements are isotopes of each other, means they will be having same chemical properties and different physical properties. So as an example, we can say that our protium, deuterium, tritium, like this, the examples will be protium means this is the representation of a protium. Then deuterium means it will be like this, and tritium means it will be like this. So these are isotopes of hydrogen. So all of them are having one proton in the nucleus, but there will be difference in the number of neutrons in them. Here it will be number of neutrons will be 1. So here what we can say is difference in the number of neutrons in the nuclei. So this is all about our isotopes. Isotopes are basically the substances or the nucleides which have same atomic number, but they'll be having different mass numbers. Coming on to the isobars, these are isotopes. The second term which we have to discuss is isobars. So isobars are nucleides which have same mass number, but they will be having different atomic numbers. So their mass number will be same. Mass number of isobars will be same. So in the top section or as superscript what we are writing, it will be same for everything, but they will be having different atomic numbers. They are atoms of different elements and have different physical properties. So their chemical properties also will be differing. I'll explain. Isobars means they will be having same mass number. That means our A will be same, or what we are writing on the top will be same. On isotope means what we are writing in the bottom section will be same, and isobar means what we are writing on the top portion will be same. So here you can identify that what will be same with the definition or with the this one with the name isotope. Top means on the top section. So what we are writing here that what is in the top is different. Bar means like basically we'll be getting an idea, or something which is on the down section will be same. So isobar means what is on the bottom side, that will be different. So what is on the name, on this name, that is different. Here top means on the top what we are writing. On the top we will be writing our mass number, so mass number will be different. And isobar means what we are writing on the bottom portion will be different, that is our atomic number will be different. So they will be, isobars are something which is having same mass number but different atomic number. So they will be having different physical properties and chemical properties, because atomic number is different means we are considering different atoms. So we'll be considering carbon 14 and nitrogen 14, so that means the whole element is different. So they will be having different physical and chemical properties. So you cannot compare here each and every element in terms of their physical or chemical properties, because they are having everything different. So as an example we can write argon 40 18, then krypton 40 19, then calcium 40 20. As I told, here what is on the top portion is same, here everything is 40. So this is all about our isobars. So we completed isotopes, isobars, and now what we are going to study is isotones. Isotones is an entirely different category. Isotones. Isotones are nucleides that have same number of neutrons in the nuclei but different mass numbers. So what is an isotone? Isotones are something which is having, or nucleides which is having same number of neutrons and different mass number. So obviously they will be having different number of protons, because here we obviously will be having different number of protons, that means different atomic number. Thus they are atoms of different elements with same properties or same number of neutrons. So they will be having different physical and chemical properties. So basically we can say in when we are comparing the three terms, isotopes, isobars and isotones, only isobar are having same chemical properties, and isobars, isotones, they are having different physical and different chemical properties. Only in isotopes they will be having same chemical properties, because in isotopes what we are considering is we are having same atoms, so their chemical properties will be same. How a hydrogen atom will be reacting, that then the same way protium, deuterium, tritium, everything will be reacting. But isobars and isotones are having different physical and chemical properties, which you have to note. Then so coming into the examples of isotones, as an example we can say silicon with atomic number 14 and mass number 30, then phosphorus 1531, then sulfur 1632. These are isotones. Likewise, another category of isotones we can say carbon, nitrogen and oxygen, CNO. This is what I have learned. CNO, so 6 carbon, 6 and 14, nitrogen 7, 15, oxygen 8 and 16. These are another set of isotones. So this is basically an introduction of the basic concepts we should know about when we are learning about nuclear chemistry. So in the next video we will be discussing about natural radioactivity, then different types of radioactive rays like alpha rays, beta rays and gamma rays. So that we will be discussing in the next video. Thank you.